So sometime back I had explained the reason behind the lift which the plane gets according to a conventional theory. So I hope you got the point that this is figure shows the transverse section, the TS of the wing. So the TS of the wing, we can see this kind of. This is not the side view of the wing. This is TS of the wing. The upper surface is convex and lower surface is flat. So then as I tried to make the plane fly with different wings and it didn't work, I suspected that there was some problem with the leading edge, and in a way I can say, according to Bernoulli's theorem, whatever wings I had created, they were not working. Then as I told, I referred internet, and I seen one video from where I picked up 2 or 3 points. Firstly, it very boldly claimed that Bernoulli was not working, and that the author of the video tried to explain by own experiments, small little ones, and also he quoted one NASA scientist who had also claimed the same thing in his video. So what points I have picked up from that video, according to which later on I made some modifications. One point was he said the Bernoulli was not working, so this was not the way the plane would be getting lift. That was one thing. And secondly, the author had shown that the wing they made something like this. So this is the way he said, this is this is the shape of the wing. They shown it, and he said that Newton's third law was working. Newton's third law was working according to this diagram, how it is applied here. The explanation was the wind was moving in this direction, it moved, and it moved from the lower side, and ultimately the wind is moving in a lower direction. So when the wind is moving in a lower direction and it starts from the upper direction, so overall when the wind moves in the lower direction, so according to the Newton's third law, the opposite force is created, and that lifts the wings, that gives the upward lift to the wings. So that the simple thing is, when the wind is moving to the downside, so it gets, wind is going downside, so it creates opposite, the lift in the opposite direction, force in the opposite direction, that is going to lift the give the upward force to the lift to the wings, upward lift to the wings. So that was, he, according to the video, the Bernoulli was not working, but it was according to the Newton's third law. So one thing was noticeable for me, that the rear edge of the wing was little downside. That was my observation. And another small little experiment which the video shown, that was they taken a thermocol piece of this shape, and they inserted say a rod through it. Maybe inserted means I should not be showing like that. So they inserted a rod through it, and then wind was blowing in this direction. Maybe they not shown it, but maybe that was done by sort of table fan or blower. So when wind was moving in this direction, wind was striking this one. So this thermocol piece, because the rod was not tightly fitting, it was loose. So the thermocol piece slowly moved in this direction, and it came out of the rod. So one thing I could see, that the thermocol piece was moving in the direction in which there was flat end. It was moving in the flattened direction, not in the curve direction, not in the direction where the thermocol piece had the curve. It was moving in the direction of the we can say the side which was flat. So keeping that in mind, my conclusion was that the force was being applied in the direction of the flat surface. So if that was the case, I argued that in the In case of this wing of this shape, again rather than getting the upward thrust, the force will be applied in the downward direction, because this was the flatter end, this was the flatter side. So it seemed, although it was very much too much bold to claim that rather Bernoulli, rather than giving the upward lift, it is giving the thrust in the lower direction. That was almost like claiming that reverse of Bernoulli was happening. But those were the conclusions I could derive from that video. Then thereafter I tried to apply these things in my experiments. So what modifications I had done? So I concluded from here that perhaps even this sort of shape is not required, even convexity is not required. This difference in the leading edge and the rear edge, this angle was what was important. So it was possible, perhaps I thought, that the wing could be made in this manner. So the air would be striking like this, and whichever direction it moved, that I think I thought would not matter. So what would happen is it would strike here, and after striking here it will be moving in this direction, and since it moved in this direction, it will, according to Newton's third law, it will give push in the reverse direction. That is, it would be giving push in this direction. So since the wind is being deflected in this direction, so the opposite force will be pushing the wings in this direction. So even what is noticeable here is even the flat wing should work. There was no need for the convexity. Convexity was not required at all. Even the flat wing should be able to work if the Newton's third law was working. So in next stage of my experiments, I tried to use the flatter wings, and let us see how it worked out. Let me explain a little more. As I explained just now, that according to my recent conclusions, even the flatter wing, if it is given an angle, it should be able to provide the lift according to this explanation. So at the same time, we can apply the same principle on this figure. Then firstly, let us try to understand this one. As I had told that this kind of thermocol piece, when the wind is being blown this side, it will be pushed towards this side. So according to that, this sort of shape, when it is moving in this direction, it should be moving, it should get the push towards the downside, because here is the flatter surface. So that means classic Bernoulli's explanation seems not to be working. So it is being pushed in this direction towards the flat surface would mean that opposite of Bernoulli's explanation was working. Bernoulli would say it should get the upward lift, but actually towards the flatter surface push means it would be pushing the wings downside. So that was very difficult to accept, but that was what logic was telling, and that was what this kind of small little experiments were telling. So I argued that if this sort of wing was giving it downward push, and this was also in accordance with my own experience. I had told some time back, when my plane was not getting the lift even after using 3 sets of wings. Lastly, rather than making it run on the ground, I thought of shooting it in the air. So when I shot it like an arrow, as we normally shoot an arrow parallel to the ground towards a target, so I shot the plane parallel to the ground, and I expected a little upward lift. Rather than getting upward lift, it didn't even go towards the ground in a diagonal manner. It didn't even take the diagonal direction towards the ground. It directly nosedived, and it crashed just a little far away from my feet with a lot of force. That made me feel as if it was being pushed down. So that was my experience, and according to this kind of logic and explanation also, it seemed as if the plane was being pushed towards downside. So that I could relate with my own experience. So according to this explanation, then I argued that if this sort of shape, if it is moving in this direction, it gives downward push to the plane. That would mean that if I reversed this shape, that means if I made it upside down, it should give the upward lift. That was rather quite revolutionary idea, and almost like absurd, but I, because the logic was supporting it and my own experience was supporting it, I thought of trying it out. So in that case, the shape of the wing, the transverse section of the wing, should be, rather than taking a convex shape towards the upper side, it should be like this, and it would be moving in this direction. And it should also work because if we apply this sort of Newton's law, this sort of Newton's law upward lift and this sort of Newton's law upward lift, if we apply it here, we would see that if the wind is striking this shape in this direction, thereafter, according to this Newton's law, the wind would be moving in this direction. Since the wind is being moved in this direction, it should give the push in this direction. That means, again, according to this logic also, the wing will be getting downward push. So thereafter, if you get the idea that if this is giving it downward push, if you reverse, rather than like this, if you turn the wing upside down, if you give it this sort of shape, then let us try to see what should happen. So if it is moving in this direction, the wind will be striking in this direction, and wind will be moving downside. When the wind is moving downside, it will give push according to Newton's law in the opposite direction, that is, it should be giving push towards the upside. So it seemed if this shape was not working, this shape should work. So I tried this shape also, and I tried this one also, and both of them worked. So upside down turned wing upside down as compared to conventional direction or the shape. It worked, it made my plane lift and fly. And this one also worked, flat wings with a tilt. That actually meant that this angle at which the air struck the wing or the object, that angle was more important. So here the angle was this way, the wind was going down, it was pushing the plane up, and here also the wind was moving in this direction, wind was going down, and it was pushing it should push the wing upside. So this worked, and this one also worked. So that now I'll be showing you with the help of videos. Let us see. So now I'm using the third set of wings which have J-shaped transverse section, and I've turned the wings upside down, and according to my experience it does give it flight little bit. And just to show you what it means by turning the wings upside down clearly, so here you can see top side is flat and convexity is towards the downside. So according to theory and my experience also, it according to theory it should give it flight, and according to experience it does give it flight. So I hope the camera catches the little flight quite clearly. Let us see. Now lastly, let us try the completely flat but angled wings, and these should give it very good flight. So these are completely flat wings, as you can see, and they are angled like this, and I have given the stoppers here, as you can see. So this is one stopper and this one is the other one. That is just because when the air strikes air is coming from this side, it strikes at the lower surface, So the wing should not get tilted like this, because otherwise these wings will get tilted like this because of a lot of air pressure. So I've given the stoppers downside to prevent that rotation of the wing. So let us see. So let us try one more time with flat angled wings with smaller bow, so that we can see that in the initial stages the thrust was not the problem. Rather, the most important factor is the angle of the wings, not even the J shape or C shape transverse section. So it again proves perhaps Bernoulli's principle is not working. Rather, the Newton's third law is working, and the angle of the wings turns out to be the most important factor. So I am almost done with it. Only 2 points more. Firstly, what I should try to make clear is, perhaps if whatever I've tried to explain turns out to be correct, then the method by which the aeroplane takes the flight, it should be similar to the one which is employed by the kite. In the sense, kite also, suppose we try to draw. So okay, let me draw a single line. So it is like this. So it is the one who holds the string, and the wind is blowing in this direction, so it gives an angle, diagonal angle. So what it means is, if the wind is blowing in this direction, the kite is not like this. Because of the angle of the string, kite is in this direction. Kite is like this, so it faces the wind, and because of that the wind moves in this direction after striking, and since the wind is moving in this direction, it gives push to the kite in this upward direction. So it faces like this, so wind is deflected downside and kite is pushed towards upside. So that is the principle on which perhaps the kite flies, and that seems to be the same principle based upon which the aeroplane gets the upward lift. So perhaps not Bernoulli, but the angle. That is one thing. And lastly, whether there is any application of whatever we have seen. Application, one can be, of course, it can be made to make better designs where angle is given more importance. Better designs of commercial planes also. And secondly, it can be also used perhaps to design a sort of joy rides, in the sense, if a vehicle, let it be any vehicle, is moving and a long rope is tied at the back of it, you can the angle. If aircraft designed the way we have designed a frame of an aircraft with one or two seater capacity inside, it is tied with a rope and pulled behind a vehicle, and of course it is having wheels, but it is not having any fuel and it's not having any motors. So if it is pulled behind a vehicle, then what are the other requirements? Perhaps let us try to see. So I have done some assessment that if the vehicle starts moving and it moves at a very high speed, tries to pick up the speed very fast, then within 1 kilometer, perhaps it can reach the speed of 100 or 120 kilometers per hour. So at that speed, according to my assessment, the plane should be able to take off. So after 1 kilometer drive, plane would be taking off, and perhaps let us see for next 2 kilometers, which will be covered by the vehicle in 1 minute. For next 1 minute or for next 2 kilometers, the plane may be made to fly in a similar manner. Plane would keep on flying. So that will give a sort of preliminary plane riding experience to the first timers. So it will be something sort of joyride. And thereafter, maybe 3 kilometers are already over. So in next 2 kilometers, cars should be slowly slowing down, and the plane will be also coming down and landing smoothly and slowly. So all total, if we get a empty stretch of say 5 kilometers, then it is possible to create this sort of joyrides. That can be one application. And we can say the pilot who are sitting inside or taking the ride, they should be given perhaps control to tilt the wings of the plane. So initially the plane wings may be kept flat. So as the car starts or the vehicle in front it starts picking up the speed, the wings can be given some tilt. So the rear edge of the wing is downside and the front edge is little upside. So as we slowly give the tilt, the plane will be getting the lift. And when we want to bring the aeroplane down, similarly the plane may be, the wings again may be made parallel to the ground. So some sort of control should be given to the one who is sitting in the plane also, and of course the speed will be controlled by the one who is driving the vehicle. So that sort of joyride is possible to design, but of course we have to be keeping in mind the legal we can say provisions, whether it is valid, and secondly whether it is safe enough. So after keeping the safety norms and the legal provisions in mind, it might be possible to create this sort of joyrides. So these are the two applications, perhaps a little better design of the planes, and this what I have explained, the joyrides. So thanks for watching the long video, viewers. Thank you very much.